The electron configuration of an atom determines the way in which it achieves the stable configuration of a noble gas. Atoms having few electrons in the valence shell tend to lose them to form positively charged ions called cations. Atoms with an almost filled valence shell prefer to accept electrons to form negatively charged ions called anions.
Noble gases, situated in group 18 of the periodic table, have 8 electrons in their valence shell, except helium with its 2 electrons. Thus, they have inherently complete valence shells. This turns out to be a highly stable configuration. That is why, in certain conditions, atoms of other elements lose or gain electrons to achieve a noble gas configuration. Look at a sodium atom and note that it has only 1 electron in its valence shell. The atom can easily lose this electron, thus exposing its complete last but one shell. The atom still has 11 protons, but now only 10 electrons. The positive charge of the nucleus is no longer counterbalanced by the negative charge of the electrons, because there are fewer electrons than protons. In this way, a sodium atom has changed into a sodium ion with a charge of +1. The electron configuration of a sodium cation is 280, the same as the noble gas neon. We can write the electron configuration of the ion in brackets and add the ion charge +1 as a superscript on the right. We create the chemical symbol of a cation by writing the symbol of its given element and adding the electric charge of the ion with the plus sign as a right superscript. Let's consider a fluorine atom. It has 7 electrons in its outer shell, which makes it much easier to accept 1 electron and fill up the valence shell than to lose 7 electrons and expose the last shell but 1. Thus, a fluorine atom accepts 1 electron and achieves a noble gas configuration. Because of the additional electron, the atom achieves a charge of -1. A negatively charged ion is called an anion. A fluoride ion has the following electron configuration: 2,8, the same as the noble gas neon. We can write the electron configuration of the ion in brackets and add the ionic charge -1 as a superscript on the right. We create the chemical symbol for an anion by writing the symbol of its given element and adding the electrical charge of the ion with a minus sign as a right superscript.